In this video, I'll be covering about the greedy approach and the subtopics, the job sequencing with deadlines, and as well as the knapsack problem. The control abstraction, or which can also be said as the general method that can be followed using the greedy method, that is algorithm greedy of A, n, where A indicates the array and n indicates the size, the number of the elements or number of items, depending upon what kind of the problem that you are solving, whether it is the knapsack problem, the number of the items. And if it is a job sequencing with deadlines problem, then it is the number of the jobs. So solution equal to empty. Initially, we are considering there are no items that are to be added within the case of the solution. And from I equal to, for I equal to 1 to n do, that is from the first item onwards, x equal to select of a, that is out of the array of the elements, list of the elements or list of the items that are present. You're picking certain kind of the item and you're placing within the case of the variable that is x. If feasible of solution comma x, the item that you have added, if it is the feasible solution, the feasibility depends upon the kind of the problem that is to be solved. As an example, for the knapsack problem, the feasible solution, that is there are n number of the items, item 1, item 2, item 3, and so on. And the knapsack has its respective capacity. Take for example something like your 10 kgs. If by picking the first item and with respect to weight, like take for example 20 kgs, this kind of the 20 kgs item cannot be placed in the knapsack with the capacity to be equal to 10 kgs. That is not the feasible solution. And what is this feasible solution? That is item 1, consider with the weight to be equal to something like 2 kgs. And the knapsack capacity has something around 20 kgs. Then in such cases, this item, that is item 1 with the 2 kgs, can be placed in the knapsack. That is the feasible solution. And if you consider the job sequencing with deadlines, that is the job that you take within the case of the X, it should be completed within the deadline. And that is how we can say about the feasible solution. And if this condition is a true condition, that is if feasible of solution comma X is the true condition, then solution equal to union of solution comma X. The item that you have picked has to be placed in the solution set and move to the next item. And if this kind of the item is to be placed in your knapsack, the condition, that is if it exceeds the beyond the capacity of the knapsack, then we cannot include. That is not the feasible solution. And if it is below the capacity of the knapsack, then we can include that kind of the item into the solution set. So you'll be adding up such number of the items as long as the knapsack capacity is not being exceeded, and return the solution. And the job sequencing with deadlines problem, that is there are n number of the jobs, and for each kind of the job, the deadline is been associated and as well as the profit is been associated. The deadline which is greater than or equal to 1, or like deadline is greater than or equal to 1, and similarly the profit should be greater than 0. And the job can be completed if and only if that kind of the job is being completed within the respective deadline. And a feasible solution is nothing but such number of the subset of the jobs that you have taken and which can be completed within the respective deadlines, and that is what the feasible solution. And there is only one machine that can be processed for all the jobs that you have considered, that is n number of the jobs, and 1 unit of the time is being taken to complete the job, and the job has to be completed within the respective deadline. And as a part of the example, consider the jobs. There are 4 jobs, that is job 1, job 2, job 3, job 4. And the next column specifies about the deadline. That is job 1 has to be completed within first 4 seconds. And job 2 has to be completed within your first 1 second itself, and so on. And the profits of the jobs like your 20, 10, 40, and similarly 30. So what does this indicates is there are various kinds of the possibilities. Like take for example here, according to this case, we can take, like take for example, we can take J2 as the first job, and then we can go for your the J1. This is the feasible solution. That is job 2, if you take this as the machine and the time slot, and similarly job 2 you're executing within your first 1 second, and then you're executing the job 1 in the next 1 second. And that is how this is the feasible solution. And what is the profit that you can earn? That is job 2's profit is 10 plus job 1's profit is equal to 20, that is 30. This is one of the feasible solution. And what are such feasible solution? You can take job 3 as the first job, and then you can execute job 1. And what is the profit? That is profit is 40 plus 20, that will be equal to 60. Between these two, this will be the maximum. This is your feasible solution. I cannot take job 3 and similarly job 4 as the solution set. Why? Because each job takes 1 unit of the time and it must be completed within the deadline. So if you consider the job 3, what is its respective deadline? Deadline is equal to 1. That is, you are completing job 1 within your first 1 second. And similarly, job 4 is having 1. So job 4 both the jobs cannot be completed within the same single slot. At any instance, only one job can be processed. And that is how we can say this is not the feasible solution. So take the another kind of the possible set, like if you take J4 and the next one, that is J1. So J4 can be completed within your first 1 second, and then J1 can be completed in your next 1 second. So what is the total profit? That is profit is 30 of job 4 plus job 1's profit, that will be equal to, that is 20. So 30 plus 20, that will be equal to 50. So this is how we can solve the problem of the job sequencing with deadlines. So here in this case, what is the maximum profit that can be earned in the context of the given problem? The given problem, we can take only 2 jobs, because here according to this kind of the example, only 2 jobs can be completed. So the solution for this kind of the job sequencing using the brute force method. This is not your actually the greedy method. This is your brute force method, where how to identify in simple regarding the case of the job sequencing with deadlines. So job 3 has to be processed first, and then job 1 has to be executed next. So the maximum profit will be equal to 60. And according to the algorithm of the job sequencing with deadlines, that is here there is a prerequisite that has to be followed in job sequencing with deadlines. That is it should be the sum of all the profits of the items that you have taken within your solution set. That is sum of I belongs to the J and Pi. That is Pi indicates the profit of each kind of the job, and J indicates it is a subset of the jobs that you have considered in the solution set. And there are 2 terminologies that are being used in your second point. That is optimal solution is the feasible solution. You are aware about what do you mean by the feasible solution. So feasible solutions is nothing but what are the possible solutions after satisfying certain kind of the condition. So out of these feasible solutions, which one is the optimal one? That is depending upon the maximization problem and the minimization problem. Since it is the maximization problem, that is job sequencing with deadlines is a maximization problem, maximum profit, whichever sequence is the maximum profit, whichever the feasible solution is the maximum, that is an optimal solution. Unlike in your previous example, there are 3 feasible solutions that we have seen with the profit something around 30 and similarly 50 and similarly 60. 60 is an optimal, and whereas 30, 50 and similarly 60, these are the feasible solutions. Out of these feasible solutions, whichever is the maximum one, that is the optimal solution. And there are certain terminologies that are being used in your job sequencing with deadlines. That is D stands for deadline, J stands for subset of the jobs, N stands for the number of the jobs, total number of the jobs. And there is a certain kind of the deadline, that is Di greater than or equal to 1, where I ranges between 1 to N. And there is certain prerequisite. What does this prerequisite indicates? That is you are aware about the binary search. Within the case of the binary search, the prerequisite is it should be ordered in the ascending order. That is, it should be in the ascending order. Similarly, within the case of the job sequencing with deadlines, that is whatever the order that is been given as an input, the profits should be arranged such that P of 1 greater than or equal to P of 2 greater than or equal to P of 3 and so on till P of n. And Ji is the ith job in the optimal solution where I ranges between 1 to k and where k is the subset range. This is a prerequisite for solving the job sequencing with deadlines problem using the greedy method. And this is your actual algorithm related to your greedy method for the problem that is job sequencing with deadline. Algorithm JS of D, J, N. The notations are familiar. D stands for deadline, J stands for the subset of the jobs, and similarly N stands for the total number of the jobs. And initially, D of 0 equal to Z of 0 equal to 0 is been assigned, and we are directly taking the first job to be processed and is being kept within your solution set. And from the second job onwards, you'll be checking whether that kind of the job can be completed within the respective deadline or not. If it has been completed, then add it within the case of the solution set. And if it is not, move to the next job, whether this can be completed within the respective deadline or not. I'll be taking certain kind of the example, which I'll explain, trace this kind of the steps using the job sequencing with deadlines problem. So consider n equal to 5. That is, there are totally 5 jobs which are being present, and the profits are being assigned. That is, profit of the first job is 20, profit of your second job is 15, profit of your the third job is 10, and so on. And the deadlines are also being provided. Deadline of your the first job is 2, deadline of your the second job is 2, and so on. This is how you can interpret the question. And here you can observe, like your no matter whatever the order that is being given, first you have to check whether it is in the format like your P1 greater than or equal to P2 greater than or equal to P3 and so on. So according to the given input, it is already in the format. P1 is greater than P2 greater than P3 and so on. So you don't have to arrange anything. You don't have to change any formats. Unlike in the scenario, like take for example, job 1 has the profit to be and profit and similarly the deadline. So job 1's profit is something like your 10 and the deadline is 2. And job 2's profit is something like your 7, and the profit is the deadline is something like your 1. Job 3 something like your 12, and the deadline to be equal to 3, and so on. There are certain number of the jobs. So here, according to this case, it has to be arranged based upon the precondition, that is P1 greater than or equal to P2 greater than or equal to P3 and so on. So you have to rearrange. This becomes your first, the 10. This becomes your first job. I'm sorry. This is not your first job, because if you consider the profit 10 and 12, that is 12 will be the maximum profit. And that is how this is your first job. And this will becomes your second job. And this is the third job. Whenever I say about your the job 1, then this will be the first job to be taken into the consideration into the solution set. So that is how you need to arrange the jobs in such a way that the jobs are being arranged in the format like P1 greater than or equal to P2 greater than or equal to P3 and so on till P of n. So according to this kind of the input, it is already in P1 greater than or equal to P2 greater than or equal to P3 and so on. So algorithm JS of D, J, N, and we have initialized, that is D of 0 equal to 0, J of 0 equal to 0. And then J of 1 is equal to 1. That is, how can you interpret? That is the first J of 1 equal to 1. This indicates job number. That is job 1. And 1 indicates the sequence. That is, which is the first job. That is job 1. And similarly, we are using some kind of the temporary variable, that is k equal to 1. And to the next case of the tracing of the algorithm, that is for I equal to 2 to n do, that is from the second job onwards. So here we are taking directly job 1 into the solution set. Why? Because according to the precondition of the job sequencing with deadlines, that is D of I is greater than or equal to 1. That is, it should be 1 or greater than 1. So based upon this kind of the condition, definitely we'll be picking up this kind of the first job and is being processed within the machine. That is the purpose where J of 1 is being assigned with the value to be equal to 1. And from the second job onwards, that is you are assigning the temporary variable R with the value of the k, that is R equal to 1. And then we'll be checking the condition while D of J of R greater than D of I. how can you interpret this condition? That is d of j of r. That is d of j of r. What is the value of your the r? That is r equal to 1. That is, we have initialized r equal to k equal to 1. So d of j of r is greater than d of I. What is the value of your the I? That is 2. So deadline of 2. So what is deadline of job 1? Deadline of your the job 1 is equal to 2, is greater than deadline of 2. What is deadline of 2? That is 2. Is 2 greater than 2? That is the false condition. That is how you can interpret this kind of your the condition. That is, while 2 is greater than 2, it is the false condition. If it is the false condition, then it goes for your the checking the if condition. Within the if condition, you'll be checking deadline of job of R. The same interpretation. What is the value of your the R and what is the value of your the I? Replace those kinds of your the values in the respective condition. So basically, if condition will be the true condition, and if it is a true condition, we'll be moving to the for loop. And within the case of your the loop, that is for q equal to k, q is greater than or equal to r plus 1. So what is the value of your the k? K is equal to 1. So q is equal to 1. According to this case, that is q value will be equal to 1, and you'll be checking, that is q greater than or equal to r. What is the value of your the r? That is 1. So is 2 greater than or equal to q equal to 1. So q equal to 1. 1 is greater than or equal to 1 plus 1. That is 2. Is 1 greater than or equal to 2? It is the false condition. So once this condition is the false condition, and it goes for your executing the next statement. That is, I is been assigned to j of r plus 1. That is, what is the value of your I? That is 2. So 2 is been assigned to j of 2. What can you understand about j of 2 equal to 2? That is, this is your second job is being placed and the processing sequence is equal to 2. And then after executing this one, the next statement that will be executed is k equal to k plus 1. Because at the end, you can observe k equal to k plus 1. So k value is equal to 2. And then the loop starts. Take the next item, that is next job, that is I equal to 3, and then assign the temporary variable r equal to with the value of your the k, that is 2, and then while condition, that is while deadline of job of r, replace the value of your r and y, and similarly check whether this kind of the condition is true or false. Basically this condition will be the false condition. If it is a false condition, then goes for your if condition, and within the case of the if condition, it checks whether deadline of job of r is greater than or is less than or equal to deadline of I. So basically this condition will be the false condition. If it is the false condition, it does not execute the body of your the if condition and directly increments the value of your the I variable, that is I value will be equal to 4, and then assigns the initial value of your the r, that is 2, while the condition will be the false condition. And similarly if condition, and if condition will be the true condition. If it is a true condition, checks for the for loop, and if it is a true condition, then assign j of q to j of q plus 1, and if it is a false condition, then assign the value of your the I to j of r plus 1. So j of 3 equal to 4. That is what I have said. That is job 4 is been assigned with the processing sequence to be equal to 3. So unlike in your previous case, we have learned like your j of 1 is equal to 1, j of 2 equal to 2, and similarly the next one is j of 3 is equal to 4. So these are the jobs. That is, take the first job, the next job to be processed is j2, and the next job to be processed is equal to job 4. And that is how this kind of your the algorithm works, and then increments the value of your the k, and then increments the value of your the I variable, and basically the while condition will be the false, while the condition will be the false, and similarly if condition, that will be the false condition, and then increments the value of your the I, and it comes out of your the loop because it is the false condition. And that is how this kind of your the algorithm terminates. So here you can observe the same thing that we have learned in your previous part. Job 1 has to be processed first, job 2 has to be processed next, and as well as the job 4. This is how you can solve the problem of your job sequencing with deadlines problem using the greedy approach. The greedy approach, how it has been implemented in JSD, that is job sequencing with deadlines, will be arranging in the order of P1 greater than or equal to P2 greater than or equal to P3 and so on, whichever is the maximum profit that you will be considering as the first job. And then the second job, and check whether this kind of your the job can be completed within the respective deadline. If it can be completed, then add it within the case of your the solution set. And this process goes on until the condition is the true condition. If it is false, then it exits. And coming to the next application of the greedy approach, the kind of the problem that can be solved using the greedy approach, that is a knapsack problem. So considering the knapsack problem, there are certain kind of how we can state the problem of the knapsack. That is maximize PIXI, where I ranges between 1 to n. That is the profit of each item. That is PI indicates the profit of the I indicates the item. That is first item, second item, third item till the nth item. And XI indicates the item that you have considered. That is whether your profit of the first item, profit of the second item, profit of the third item, and so on. And subject to the condition WIXI less than or equal to M. M stands for the capacity. W stands for your weight. As I mentioned within your knapsack problem, that is there is a certain kind of the knapsack, that is bag, and which has certain kind of the capacity, that is something like 10 kgs. That is M equal to 10. And here the condition that has been used is nothing but whenever you are adding the item into the knapsack, it should be in such a way that it should not exceed the capacity of the knapsack. If it exceeds the capacity of the knapsack, then we cannot include that kind of the item into the solution set. And here you can observe 0 less than or equal to xi less than or equal to 1. That indicates about the fractional part. What does it mean? There are two different kind of the terminologies. That is greedy knapsack, and the next one is of the 0 or 1 knapsack. So here the name itself indicates that is the knapsack problem, that is which can be solved using the greedy approach, or which can be also said as it is fractional knapsack problem. That is one concept. The other concept is 0 or 1 knapsack. Basically this can be solved using the dynamic programming. So fractional knapsack indicates you can take the fraction of the items. That is, you can add the first item, check the condition whether it exceeds the knapsack. If it is not, then include the item 1, include the item 2. And when you are adding something like your item 3, then it cannot be, then it exceeds the knapsack capacity. Then in such cases, the portion, something like your 2/3 of item 3. How to calculate this 2/3? That will be discussed in your next part. That is, a fraction of the item 3 can be taken into the solution set. That is what the fractional knapsack can be included. And coming to the 0 or 1 knapsack problem, which can be solved using the dynamic programming, that is either you have to take complete item or drop that particular item. We cannot have the portions of your item to be taken into the solution set. That is what the difference between the greedy knapsack and the 0 or 1 knapsack. And we can solve the problem of the greedy knapsack because we are considering about the greedy method. Same thing which I've said regarding the case of the knapsack. That is, there is a certain kind of the bag which can be some kind of the cages, like your 15 cages, and there are items which are being provided, and each item has the respective weight and the respective profit which has been associated. And what is the problem of the knapsack? To determine the items which are to be included in your respective knapsack such that it earns the maximum profit. So as a part of the example, consider the knapsack capacity M equal to 50 with the items. That is, there are 3 items. First item, item 1, item 2, item 3, with respect to weights and with respect to profits. That is, weight of the first item is 20, second item is 10, and so on. The profit of the first item is 100, profit of the second item is 60, and so on. And this kind of the problem has to be solved using the greedy approach. As you have learned within the job sequencing with deadlines problem, there is a prerequisite. What is it? That is, if you recall the prerequisite, that is P1 should be greater than or equal to P2, greater than or equal to P3, and so on. And here in this case, within the greedy knapsack, it should be arranged in the order of the P1 by W1 is greater than or equal to P2 by W2, and so on. That is, it should be arranged based upon your Pi by Wi. How to arrange this one? That is, here the jobs are being provided. That is, these are the items. That is item 1, and similarly item 2, and as well as item 3. and its respect to profits. The profit of your the first item is 100, profit of the second item is 60, and similarly 120, and the weights are been that is 20, and the next one that is 10 as well as 30. So no matter whatever the order that is been provided, you should arrange in pi by wi, that is pi by wi. So you should arrange in the pi by wi format. So what is this pi by wi? That is p1 by w1, that is 100 by 20, that will be equal to 5, and here 60 by 10, 60 by 10, that will be equal to 6, and the next one that is 120 by 30, that will be equal to 4. So this is your first job, I mean first item that has to be taken into the solution set. And similarly this is your second item, and this is the third item. As I mentioned, it should be arranged in the format of pi by wi, that is pi by wi greater than or equal to, I mean p1 by w1 greater than or equal to p2 by w2 greater than or equal to p3 by w3, and so on. So whenever I say about your the first job, then you have to consider I2, that is the first item. So it should be ordered in this particular format. And the next thing is, as within the question itself, it has been given the knapsack capacity. That is, knapsack capacity is equal to, that is here 50 is being provided. Knapsack capacity is equal to 50. And take the first item. When I say the first item, this will be the first item. So take the first item, and what is the weight? That is, weight is equal to 10. And by adding 10, whether it exceeds the knapsack capacity, it does not exceeds the knapsack capacity. So item 1 should be included. In the case of your I'm sorry, it is item 2, because the first item is item 2. And item 1, that is item 2's weight is equal to 10. And how about the remaining capacity? That is 50 minus 10, that will be equal to 40. What does it mean? The knapsack can hold the remaining weight to be equal to 40. And take the second item, I mean the second item in the order, like this will be the second item. And what is its respective weight? That is 20. So if you include 20 into the knapsack, can it weigh? Can it hold? So what is the remaining capacity? Remaining capacity is equal to 40. And what is the item that you are adding with the weight? That is 20. This is feasible. So by adding the next item, that is item 1, m equal to, that is 40 minus 20. That is, you are adding item 1. And how about the remaining capacity? 40 minus 20, that will be equal to 20. And consider the next item, that is item 3. And what is the weight? That is 30. So you are adding more weight than the capacity. And this entire item cannot be placed into the knapsack. Why? Because the remaining weight in your knapsack is 20 kgs. And you are adding 30 kgs into the knapsack, which is not possible. That is, it is not the feasible solution. And as I mentioned, this is your fractional knapsack. And what is this fractional knapsack? You can break this kind of the item into portions. How much portion has to be added? It depends upon, here in this case, that is 20. So 20 is the remaining balance. And what is the weight of the third item? Third item's weight is 30. So 20 by 30, that is 2/3 of item 3 should be added within the case of the solution set. That is 2/3 of item 3 should be included within your solution set. And that is how we can solve. So we can also check the weight. That is item 2's weight is equal to, what is item 2's weight? That is 10. And similarly items 1 weight is equal, items 1 weight is equal to 20. And 2/3 of item 3, that is 2 by 3 into, 20 by 30 into 30. That becomes, that is 2. 2/3 into item 3's weight, that is 30. So 3, 10, that is 20. That is, what is the total weight? That is 50 kgs. So this is how you can solve how much portion of the item should be added. What is the objective? You need to find the profit. So to maximum profit. So profit equal to, since you have added the entire item of 2, that is item 2's profit is equal to 60. 60 plus item 1. Item 1's profit. Item 1's profit is equal to 100 plus And what is the 2/3? That is 2/3 of that is remaining capacity. That is 20 by 30 into what is the profit of your the third item? That will be equal to 120. So 30 and similarly 40, 4, and the total profit will be equal to 60 plus 100 plus 20 into 40. That will be equal to 80. That is 240. This is how you can solve the problem of this kind of your the solution. The same thing has been explained. That is 240. And coming to the algorithm, that is algorithm has certain kind of your the precondition. That is P of I to N and 1 to N certain contains the profits and weights respectively, and it should be ordered based on Pi by Wi greater than or equal to Pi plus 1 by Wi plus 1. And similarly, that is for I equal to 1 to N2, that is from each job that you consider, initially solution equal to pi. That is x of 1 equal to 0, x of 2 equal to 0, and so on. U equal to m, where m indicates it is a capacity, and you are keeping this in your temporary variable, that is u. And for the first item onwards, if w of I is greater than u, that is the weight of your the first item or any item that you are including, if it exceeds the knapsack capacity, then or the remaining capacity, then break. And if it is a false condition, take that kind of your the item, that is x of I is equal to 1.0, your entire item. And similarly, u equal to u minus wi, the remaining, how to find the remaining capacity, which has been given by u equal to u minus that kind of your the item's weight. And at the last, that is you'll be checking if I is less than or equal to n, then x of I equal to u by wi. That is how to find the portion or the fraction part. That is how you can use the statement x of I equal to u divided by wi. And I will provide with an example to solve the same kind of the algorithm. So consider m equal to 10, that is capacity equal to 10, knapsack capacity equal to 10, the profits equal to 2, 3, 4, that is profit of the first item, second item, third item, and so on, and w equal to 4, 5, 7. So the first prerequisite that you have to understand is item 1. And similarly, what is the profit and what is the weight? The profit is equal to, that is 2, item 2, and similarly item 3. So item 2's weight is 3, profit is 3, item 3's profit is 4, and w, that is 4, 5, 7. You have to arrange according to pi by wi. So when you arrange these items into the pi by wi, then you can observe that is pi by wi equal to, that is p1 by w1, p1 by w1 equal to 0.5, similarly 0.6, and as well as the 0.57. So this will be your first job that has to be taken into the solution set, and this is your second job, and this is the third job that has to be taken into the solution set. So take the first item, and what is the weight? That is weight equal to 5. What is the capacity? That is 10. What is the remaining capacity? That is 5. So here you cannot add the entire second item. Why? Because the second item's weight, what is the second item's weight? That is 7. And 7 cannot be included with the knapsack capacity, remaining knapsack capacity of your 5. And that is the purpose where here, what is your remaining balance? That is 5 divided by what is the weight of your that kind of your the item that you are considered, that is 7. So 5 by 7 of that kind of your the item should be taken into the consideration. And how about the profit? That is 3 plus, that is, what is this 3? Profit of the first item. When I say the first item, that is pi by w, that is 0.6. And what is the profit? That is 3. That will be equal to 3 plus the second item. What is the second item with the profit? That is 4. So 5 by 7 into 4, that will be equal to 5.84. And take another example okay, I'll move to the next one. Consider the naps n equal to 6. That is, there are totally 6 items which are being present, and the profits are being provided. That is, profit of the first item 18, profit of the second item 5, and so on. The weights are being provided. Weight of the first item 7, weight of the second item 2, and so on. And the knapsack capacity is being given with the value to be equal to 13. And how can we trace based upon the algorithm that is being provided for the greedy knapsack? So algorithm greedy knapsack m comma n, where m indicates the capacity, n indicates the number of the items, for I equal to 1 to n do, that is x of I equal to 0. So this step is basically used to initialize the solution set. That is x of 1 equal to x of 2 equal to, for how many number of items that are being present, you are saving it, you are storing with the value to be equal to 0. And then u equal to m. U is a variable that has been used to find the remaining balance or the balance that has been present. And initially we are assigning to the knapsack capacity. That is, here the capacity is equal to 13. That is u equal to 13. And for I equal to 1 to n2, for each job that you are, for each item that you are considering, if w of I is greater than u, so what is the weight? So you need to arrange according to the base of your the pi by wi. That is been left as an exercise. That is item 1 and similarly item 2 and so on. And the profits are being associated like your 18 and similarly 5 and similarly 9 and so on. And the weights of your item 1, that is 7, 2, 3 and so on. You have to arrange based upon pi by wi. That you can do it as an exercise. What is the value of your the 18 by 7 and so on. So based upon this one, whichever is the maximum one, that will be the first item. So based upon this, if w of I is greater than u, the weight of your the first item will be equal to 3. Once after you calculate pi by wi, whichever is the maximum one, that is your first item. So 3 is greater than 13. What is this 13? That is u. What is this u? Since initially you have assigned u equal to m, that is knapsack capacity. So 3 is greater than 13, it is a false condition. If it is a false condition, then take the entire first item, that is x1 equal to 1. And you need to also calculate the remaining balance that the knapsack can be hold. That is u equal to 13 minus 3, that will be equal to 10. And then take the next item, that is I equal to 2. And then weight of that second item, that is equal to 2. Check whether 2 is greater than 10. It is a false condition. If it is a false condition, then you can take the entire item, that is second item, and calculate the remaining balance. And then take the third item and then check the condition to satisfy the precondition of your the knapsack. 3 is greater than 8, it is a false condition. Then you can take the entire third item and then the remaining balance, u equal to 8 minus 3. So it is nothing but, here the previous balance is 8 minus the current item's weight, that is item's weight is equal to 3. So 8 minus 3, that will be equal to 5. And then take the next item, that is fourth item. So here the fourth item's weight is equal to 7. What is the remaining capacity? That is 5. 7 greater than 5, it is a true condition. If it is a true condition, then break. Then find out what is the fractional part. The fractional part is, that is x of 4 equal to, what is the remaining balance that is been available? 5 divided by what is the weight of that kind of your the item, that is 7. So 5 by 7th of that kind of your the item should be taken into the consideration. That is the fourth item. And how to calculate the profit? That is x1 plus x2 plus x3. That is entire first item, entire second item, entire third item. And whereas the fourth item, that is 5 by 7th into x4. Once you calculate this one, that is weight of your the first item, it is 12. Second item, profit of your the first item is 12. Profit of your the second item is 7 and so on. 5/7 of your the item 4, that is equal to 12.85. And that is how you get the maximum profit. That is the profit is equal to, that is 40.85. This is how you can solve the problem of your the knapsack problem. So consider the same example, that is n equal to 6, and similarly the profit is equal to 18, 5, 9, 10, 12, 7, and similarly the weights are being assigned 7, 2. I believe like they have covered the similar kind of here the example in this case. So that is how we can say how this kind of here the knapsack problem can be solved using the greedy approach. That is, there are various other problems that can be solved using the greedy method. As I mentioned, that is, we have the job sequencing with deadlines problem, and similarly we can solve the knapsack problem using the greedy approach. And similarly we can also solve the minimum cost spanning trees using the greedy approach, and as well as we can also go for the single source shortest path. So there are various kinds of the strategies which can be involved in order to solve a particular problem. That is divide and conquer. And similarly, we have the that is a greedy approach. And the next one is of the dynamic programming, branch and bound, backtracking. There are various strategies. Depending upon the problem, we can solve whether it is it can be solved using the divide and conquer. If you recall about the divide and conquer, there are various problems that can be solved using the divide and conquer. That is, merge sort is one of the example, quick sort is one of the another example, binary search is another example, finding Strassen's matrix multiplication, and so on. So here, according to the greedy approach, we can solve the problem of the knapsack. We can solve the problem of that is specifically about 0 or 1 knapsack problem. I mean, sorry, fractional knapsack. So regarding the 0 or 1 knapsack problem, that has to be solved using the dynamic programming. So that will be discussed, or that will be explained in your next part. So this video ends according to this case.